What we will be doing here is taking a look at the exercise set that is found at the end of your lesson on topic 1.1 in your textbook. So we're going to take a look at these and see, as we look at each example, what you think the answer is. So for this first one, we're asked whether these examples are of the product rule, the quotient rule, the power rule, raising a product to a power, or raising a quotient to a power. All right, let's take a look at these, and I think what we can do is actually number them. So you don't need to write these down, but in a sense we're going to write 1 through, let's say, 10, and then we're going to ask you, is it a 1, a 2, a 3, a 4, or a 5? So let's take a moment, we'll pause and see what you end up with. Okay, we can check our answers. Now here, this is the power rule, that we're raising an exponent to a power of 4, and there we would multiply. The power rule, we multiply. Now this is raising a quotient. Quotient is a fraction to a power, and keeping in mind we're going to multiply, there's a 1 by each of these, so this 1 times 4 will be 4, so 5 to the 4th, 7 to the 1st power. The 1 times the 4 gives you a 4, 7 to the 4th. So this is raising a quotient to a power. In number 3, now notice this is a product here, 5 times x. So number 4, raising a product to a power. So there's a 1 by each of these, and we're going to multiply. 1 times 7 gives you a 7, 5 to the 7th. 1 times 7 gives you a 7, x to the 7th. So again, practicing the names and how it works is a very useful skill. Here we have a fraction with exponents. What rule do we use? Well, it's the quotient rule, where we take the smaller number, crosses the division bar, and the sign of the exponent changes. So as it crosses this bar, this 3 comes up as a -3, leaving us with m to the 6th. Now the first of our rules is the product rule. That is, when we are multiplying variables, we just add the exponents, and we get m to the 10th. So this is where students often get confused. What rule do they use? Do they add here, or do they multiply? Do they add here, or do they multiply? Now, if you know the rules that you're using, you realize this is the power rule. We multiply. In number 1, this is the product rule. We add. Okay, and I think we've covered all of these, and we want to work on some examples over here. So I'll leave that up, and what I'd like you to do in your booklet or wherever you have room, just do these. And you don't need to write out the examples. This is just a little exercise here. All right, let's pause and see what you get for answers. Now, keep in mind that this is from your textbook, and these answers to the odd examples are in the index at the back of your textbook. They always give you the answers to the odds. And the even is just to challenge you because those answers aren't there. So take a look. Here we're just going to add the exponents. Now, any exponent that is a 0, the base just becomes a 1. So when we're adding m to the 9th times 1, this is just a 1 here, then that just becomes m to the 9th, or 9 plus 0 is 9. Here we have two negatives. That's going to give you a positive, and again you just add your exponents. And here it's a little tricky. Z to the 0 power is 1, so that doesn't appear in the answer. So you can check these. We'll pause. If you have a question on anything, be sure you are asking your questions. Now notice it's -2 times 7. A negative times a positive gives you a negative. Now in these cases, we're just going to divide the numbers and subtract the exponents. Now in the older class, before we use the computer to do our homework, we would assign examples to the students. This is what they would be putting in their homework logs. But you have your practice, and then later your quiz me, where you can develop the techniques needed to solve. So let's just do a few of these. For instance, here we have a base of -2 that's raised to the 4th power. Well, what will that become? Well, an interesting thing is if you have a base that is negative and you are raising it to an even exponent, your answer is going to be positive. Let's see if we have some that are odd here. Not there. All right, all of these, in this case, our exponents are even, but here we have to be careful. Let's take a look at this one. So this is a -2 that's raised to an even exponent. Our answer is going to be positive. What is 2 to the 4th power? Well, 2 times 2 times 2 times 2 is 16. So this will end up being 16, a positive 16. Now over here, what is our base? Well, our base is 3. You might say, well, what about the negative? No, the negative is not part of our base. So here whatever we get when we raise 3 to the 4th power, which is 81, I happen to know that one, we then apply the negative to it. So here, because the base includes the negative sign, and it's to an even exponent, your answer is positive. Here, this is an even exponent, but our base is only the 3. It does not include the negative sign. Now, if it were in parentheses, then this would be a positive 81. But because of the way it's set up, 3 to the 4th is 81. Then we apply the negative. Now, for our negative exponents, and we haven't reviewed a lot of those, so let's just do that again. We have a negative 4, and our base is negative, our exponent is negative 2. Now, what's our base there? Well, our base is only the 4. So, in a sense, the negative is going to stay there. Our 4 goes down to the denominator, along with the negative exponent, that as it crosses the division bar becomes positive. It changes its sign. And we have to remember there's a 1 then up in the numerator. So, in a sense, this is what 47 is. Now, what is that? Well, the negative remains 1 over, and as we expand 4 to the 2nd, that becomes 16. I see they use here every once in a while too. Sort of interesting. And some of these get rather challenging. Well, okay, I didn't want to make this too long. If we do have time, we could look at some of these others. And we'll wind this up.